Well, I think we're going to move to the next presentation first. And then have our questions. Oh, I'm sorry. Yeah. Can I get it back to you?
Okay. So first things first. Because of ILA, you are unable to see a robot trying to cross a threshold. The DARPA robot trying to fall off, like crossing the threshold, but you just have to imagine it. For some reason, the GIF doesn't work. Before I start talking about AI thresholds, I also wanted to do a quick summary of what happened yesterday, because especially for the benefit of some of those of you who have found a really large bourbon bottle in the middle of the night. There's this book that all of you know, that All I Needed to Know about life I learned in. That we learned in kindergarten. I found that it's very interesting that yesterday we have gone further on that. It's not just kindergarten. We may have learned it in the first few hours of our life, and maybe even pre-conception. That's something I think worthwhile to understand, because this is like a total contribution. Pre-birth, okay. And then the other thing that I wanted to say is that as I was sitting there hearing some of the talks, I found that all I needed to know about the control problem, I learned from the Dilbert cartoons. It turns out they're just a Dilbert cartoon for every possible control problem. This one is telling you about the Asimov's laws and how that's going to completely control the superhuman intelligence. And then there is this one which talks about how important it is to have hidden goals. It turns out that the way apparently to control superhuman intelligence might be the way you control humans, make them feel inadequate all the time. Okay. So if you make them feel inadequate, they can't take over. Okay, anyway, so it gets back to the AI thresholds, and in some sense, it's kind of a strange thing to talk about. On one hand, the AI person in me is just happy that we are where we are, but I'm also feel compelled to tell you, don't worry, you don't need to pay us protection money. There's still a long ways for us to go. So it's like an interesting dichotomy of feelings in talking about thresholds. So to talk about thresholds, first of all, we have to ask, what are the thresholds for? What are we trying to cross? Are we trying to reach super intelligence? Are we wondering what is the 0th level is, what's the time when AI can do real damage? I'm here to tell you that software can already do real damage. So I guess that part we have already taken care of. Now, are we talking about reaching the super intelligence? Are we talking about reaching human-like or human-level intelligence? This came up a couple of times yesterday. You could reach super intelligence without having any sort of human-like intelligence. But keep that in the back of the mind. And then since we mentioned the human intelligence, I just quickly want to point out that obviously there are multiple different kinds of human intelligence. We tend to spend, in the beginnings of AI, we focus a lot on the cognitive and the reasoning tasks that humans are not all that good at doing. That's why the SATs, etc., test you on that. It's very rare for an SAT exam to show a picture and say, can you see what's in that picture? And yet, that's the stuff that we make, that the human babies have that from the day one. And so that's the one we use for captchas. We barely ever talk about emotional and social intelligence. And I tend to think that it's because the very fact that the male engineers are as successful as it is sort of shows that emotional and social intelligence are probably not needed. In fact, when I give this talk to my students, I point out that emotional intelligence, it's the stuff that the men among you don't have, and the social intelligence, it's engineers among you don't have, and apparently you can get by. But anyway, these are actually important, as we find out when we actually talk about intelligence that interacts with humans in the loop. Okay, so then the AI's progress, obviously, it's for those of you who are outside of AI. So obviously, we had this huge big thing about expert systems in 80s. There is reasoning systems that dethroned Kasparov in 90s, and then we started making great progress on perceptual tasks in 2000s, and until very recently, I guess we're making great progress there. And currently, in some sense, maybe we have to connect reasoning and perception. The interesting thing to keep in mind to me is the progress in AI has been exactly the opposite of the way human babies make progress. They first figure out how the world manipulative intelligence, perceptual intelligence works before they figure out how to take SATs. And computer programs more or less could take win chess before they could actually see the images, right? So that's sort of an interesting thing to keep in mind. So we have made sort of interesting great progress. Are we there yet? Okay, I mean, so I guess it's like a bunch of kids sitting in the car and saying, are we there yet? Are we there yet? So at any given time, any interesting technology that is working makes you think that's pretty much it. That's all we need. So obviously we are not alone in this. This guy Archimedes thought if you just give him a big enough lever, he can lift the universe. And then this guy called Ed Feigenbaum thought in 80s that all we really need is to keep up with the evil Japanese is to do the fifth generation project. It's like nowadays put a list machine, maybe 3 list machines in every possible desk, and there's nothing that can stop us from world domination. And then of course the latest version is give me a big enough GPU, large enough data set, and deep enough network, and I'll create you super intelligence. Now, I'm not necessarily saying that people who are in the know are saying it, but it's not, there are enough misunderstandings about this, obviously. So I love this quote from IEEE Spectrum. IEEE Spectrum, this is like the flagship magazine of IEEE, which was writing about AlphaGo before it actually started having, I think, the first part of the AlphaGo in January, and then basically said, yeah, those guys say there is reinforced learning, but really we know it's all deep learning, nothing else. So even if we are careful about what has been done and what still needs to be done, it's, the press is out there sort of misrepresenting, and then we probably have interesting issues with respect to that. But anyway, so the rest of my thing is that are we really there yet, and what sorts of some important technical challenges I see waiting. Obviously, there are other people who have much more different opinions. I'll start with the still elusive common sense. We talked about it a lot. So the world is full of obvious things that nobody by any chance ever observes. So there are not enough Facebook videos that you can observe and figure out everything. It's like, and this, by the way, for people in AI and also actually thinking about this, it's a very beautiful book called Curious Incident of the Dog in the Nighttime about an autistic boy. It's a, autistic boy is an amazingly intelligent guy who misses certain types of common sense that we take for granted. This guy also basically says, so he was actually, turns out that he was just channeling something that Sherlock Holmes said before in Arthur Conan Doyle. So this stuff is actually, there's a lot of issues about how do we actually acquire common sense. Everybody and their brother has an opinion. We have been wrong many times, including now, I think. So our systems, by and large, are still idiot savants, and giving them common sense remain a big threshold. Psych, lucid, and video watching notwithstanding, it's still a pretty darn open problem, and it's a threshold that we haven't yet crossed, and it will be worthwhile working around it. Now, common sense, oftentimes people tend to think of this as it's just extra knowledge that we just try to figure out about the world. It turns out that it's sort of the glue that makes large amounts of unsaid things come into play. It's not just the facts, it's the knowledge about the world, it's even about the observations and about the norms and goals of the world that we are expected to be living in. So for example, there is which trip did explorer Magellan die? I hope you had enough time to think about this yesterday night and figure it out. Turns out the number 3, okay, and then there is this perceptual task. So Sebastian Thrun was once pointing out that Google car essentially saw a flying grocery bag and was with very high certainty figured out it's a flying deer, right? Now, how the heck do you actually realize that it can't be a flying deer? We do it because we haven't seen deers flying around in San Francisco, okay, which is where they're driving. So there is a lot more than what you see. You bring to bear large amounts of background knowledge. And then, I don't know how many of you are Seinfeld fans. There is George Costanza once, who actually has a rather amorous, interaction in his office with the office maid, and then goes to his boss and says, "Really, are we not supposed to do this? Where is it written? Why don't when you get into a job, nobody tells you you're not supposed to have certain sorts of interactions with the but again, this is common sense. So it's like the goals themselves are partially specified, and you expand the goals using common sense. Okay, so common sense is a huge, big, elusive part that we have to figure out. One other thing is in the second type of broad challenge is how do we get robust and safe decision making in the context of mostly incomplete models and unspecified or partially specified goals. Okay, so Bart pointed out, for example, all the great challenges in great progress in planning. I think it's great. We have been involved in that sort of stuff. But one of the interesting things is that there's been this disconnect in AI. The planning and reasoning people have focused mostly on complete models and planning as pure inference. You never have complete models. You always have incomplete models, and you are trying to do the best with respect to that. The learning people might say, let's just wait until the model becomes complete. That never happens until you die, and even then it's only partial. So the question is, at any given point of time, you're talking about risk-aware exploitation of the model you have. And I think Tom gave a very nice talk at AAA about this idea that how do we get into talking about robust decision making in the context of incomplete models, and that's something that Bezad has been supporting us for a bunch of time, and how to do planning and decision making in the context of incomplete world models, incomplete objectives. Now the interesting thing is the problem becomes harder. If you're talking about optimality, the problem becomes quite harder, and it'd be a big challenge as to figure out how to do this. And then, in fact, this is sort of probably too much technical, but so the idea that most of the work in some of these fields has been done with complete models on one hand versus not having any models on the other. We actually need to start thinking about what sorts of representations are the right ones to support these kinds of, even talk about your, uncertainty and incompleteness about the world that you are in. Okay, I actually like to think of Don Rumsfeld, who is the full-time philosopher, defense secretary that we had, who basically talked about this idea that there are known knowns, there are things that we know, and there are known unknowns, and then there are unknown unknowns. And we have to talk about models which actually are incomplete at these different levels, and talking about how do we provide robustness. So in fact, yesterday, most of our discussion was how to stop the superintelligence when it knows what it is doing. Okay, most of the time, ignorance can cause a lot more damage without malice. You don't need malice on these agents' part. If they are dealing what they consider is an optimal action with respect to an incomplete model, they can be doing a lot of damage. So from the point of view of safety consciousness too, it's important to understand how to handle these things. Shifting gears a little, we keep talking about superintelligent AI. The question that I have, because I mentioned these two things about emotional and social intelligence, would superintelligent AI have super social and super emotional skills? I'm really hoping for a superintelligent AI which is always weeping, because anytime anything goes wrong, then they probably can't get on us. But the reason that's kind of interesting to me is actually within AI, there's always been this sort of a dichotomy as to, are we trying to replace humans? We are always trying to win over humans. We are trying to say, basically, do better than humans. But there is also this issue of, can we just start talking about augmenting human intellect, human intelligence? And if you start looking at that, it's not clear to me that a superintelligence really necessarily has to have emotional or social intelligence, because a dictator doesn't need emotional and social graces. They're omnipotent. Okay, but if you're working with humans, pretty much, if you're talking about generating machines, systems that work with humans, it's going to be very important to consider those issues. And in some of the other problems that we already talked about incompleteness, come back in spades. Not only do I not know, if I'm a robot, about the world and about what you're asking, one of the biggest blank spaces, the sources of incompleteness is what's going on in the human's mind, what's going on in the other agent's mind. What are they thinking about? What are their intentions? What are their desires? What are they trying to do? And so you now have incompleteness at a second order, and that too you have to handle. And you have to be able to manipulate that too to some extent to make sure that they understand, the humans in the loop understand what you're trying to do. Let's see. There is this whole issue of so one of the other things is that's where all this stuff about explanations, justifications, and trust come into play. Again, a super intelligence doesn't by itself have to deal with any of this, but in fact, if you're talking about intelligence systems that is working with humans, these issues become quite important. And this issue of explanations being, when you're trying to explain somebody why a particular decision is right, you have to explain that in the context of their model, not in the context of your model. People tend to confuse explanation as a trace of their own reasoning. That's like, those would make the worst teachers in the world, because it's all about the other people's models, other people's minds, and that is significant incompleteness on about that. And in fact, this is just a thing from a trust and autonomy workshop that I think Selmer and I were there. There was this whole issues about how do these agents start actually gaining trust of humans, and to understand that you have to actually understand how trust works in human societies. So this actually brings back some interesting issues and civil wars that are going on within the community itself. There is this whole issue of symbolic versus symbols versus neurals positions. In fact, sort of exemplified by Simon's and Newell Simon's symbol system hypothesis versus Jeff Hinton's symbols are just luminiferous ether of AI. We don't really need them. Maybe, maybe not. But if you want interpretable AI, if you want AI systems that have to work with humans, we seem to need our symbols. I'm talking to you in symbols. I haven't yet figured out how to USB plug into your heads. Okay, and so there is a lot that we need to actually have to still deal with in terms of explanations, comprehensibility, and basically having trustworthy collaboration. One other top level thing I wanted to mention, this came up a couple of times yesterday, there's this whole thing about, that thanks to Stuart, there's this thing about systems. What is goal of AI? Systems that think like humans, systems that think rationally, that's systems that act like humans, systems that act rationally. In the beginning of AI classes, we put it up, throw out the 3 straw men and say, my God, this is what we want to do. That's no longer true if you actually have humans in the loop. If you have humans in the loop, you do want to act like humans, because we don't seem to like anything other than other humans. Okay, and so we tend to anthropomorphize, and we tend to actually you don't learn anything that you don't already almost know. Well, let me complete my point. So the question then is that at the beginning of this AI, we used to have this large amount of connection to cognitive science and psychology and so on. That sort of may have become less important, but I think it's coming back in spades. The whole entire issue of whether or not Elon Musk is out of his mind when he thought it's an optimal thing to change the entire interface overnight. You can only make sense of it once you understand that there are human factors involved, and it's apparently we don't seem to like that sort of a changes in thing. Okay, one last thing I want to mention, which I probably have to have too much time, is from the point of view of learning. We keep talking about all the amazing progress in learning, but really what I need is McCarthy's advice taker. Okay, I don't tell anybody, some